Yeah, good morning, students. In the previous session, we discussed regarding the operators like the logical operators as well as arithmetic operators and increment decrement operators, conditional operators. We discussed it till now. Now, the another important kind of operators that the C language supports is the bitwise operators. As well as we are going to see some special operators which are supported by the C language. So now I would like to share my screen. So is my screen is visible? Yes, I hope. So in this topic, operators in C, so we are going to discuss about this bitwise as well as relation special operators. This is what about the outline of this today's classroom discussion topic. Then the lecture objectives is this. This session will develop the students' knowledge on bitwise and special operators available in the C language. So the lecture outcome is after completion of this session, students will be able to develop the programs using bitwise as well as special operators. So what do you mean by a bitwise operators? So the bitwise operators are going to operate on the bit level, binary data. They are going to operate on the binary data. So the following are the bitwise operators. So single ampersand, which is called it as a bitwise AND, single pipeline symbol, bitwise OR. So this is the cap symbol, so which is called it as a exclusive OR, bitwise. So this is the tilde symbol, which is called it as a ones complement, unary operator. And these are the two important shift operators. One is called it as a left shift, and this is another one is called it as a right shift operator. So less than left shift, and greater than is a right shift. So these are the different kinds of bitwise operators we have. So if you take this bitwise AND operation, if you take it as, so if the first operand bit is 0 and second operand bit is 0, then the result will be 0. 0 and 0 is 0. So this is similar to the logical AND operation. If two conditions are true, then only the result is true. So here if two operand bits are ones, then only the output is 1. Otherwise, output is 0. Similarly, bitwise OR is operating like this, logical OR. So if two bits are zeros, first bit and second bit is 0, second operand bit is 0, then the result is 0. If at least any one of the bit is 1, the output is 1. This is exclusive OR, bitwise XOR we can call it as exclusive OR operator. So in this exclusive OR operator, if you carefully observe the result here, anyone can interpret that. Any student can able to interpret that when we are going to get 0 output. So if both input bits are 0 and if both input bits are 1. So that means if both the two input bits are similar. So here 0 and 0. Okay, two operand bits are similar, output is 0. Okay, two operand bits are similar, output is 0. If two operand bits are different, output is 1. So this is what XOR. So this is another ones complement. Ones complement, it will just perform the negation. So 0 complement is 1, 1 complement is 0. Fine. Then next coming to this shift operators. So it shifts the bits to left side as mentioned by the operand. So if x is equal to 3, if you write x less than 2, that means you want to shift the value of x by left 2 bits positions. Okay, 2 bit positions you want to shift that. So for example, x is equal to 3, if you represented in 8-bit format, so it will be represented like this 0 0 0 0 0 1 1. So in the binary format, so the 3 value is represented like this in 8-bit format. So if you left shift this, that means you are removing this leftmost 2 bits, and this right side you are adding 2 zeros, we are inserting that. You are appending these 2 zeros. So what happened here is that its value becomes 12. So that means The left shift operation performs the multiplication by 2 power. How many bits you are shifted? So we have shifted 2 bits. 2 power 2 means 4. So the original operand value is 3. So if you left shift 2 bits, this 3 value you are going to get it as it is multiplied with 4. 4 into 3, 12 you are going to get. So in the above example, 3 into 2 power 2, which is equal to 12. Fine. So the left shift operation always implements the multiplication by 2 power. How many bits you are shifting? So then coming to the right shift operation, so it shifts the bits to right side as mentioned in by the operand in the expression. So for example, if you consider x equal to 12, so that x equal to 12 will be represented in the binary form. Okay, x equal to 12 will be represented in the binary form like this. So its value is represented as, okay, 0 0 0 and then 1 1 0 0, its value 12. So if you are left shifting by 1 bit, so that means here the left side, okay, so here the left side bit will be, so left bit, if you are, this is a right shift operation, na? So this right shift by 1 bit means rightmost bit will be gone. So this sign bit extension will be done because here the bit is 0 is there, so 0 will be appended here. So that means the value becomes 0 0 0 0 0 1 1 0. That means it becomes it as 3, not 3, it becomes it as 6. Similarly, if you again shift x value by 2 bits, so it will be removing again this bit and 0 will be added here. So that means it becomes it as 3. So what it is performing here, the right shift operation always performs the division operation, division by 2. So in the example, 12 is your original input. So if you are shifting right by that 12 value 1 bit, so we are dividing 12 by 2 power 1, which is equal to 6. Similarly, if you shift that 12 by 2 bits right, so we are performing 12 divided by 2 power 2, which is equal to 12 divided by 4, nothing but 3. So it performs the division operation. So then coming to the special operators. So there are some special operators which are also supported in C language, like comma operator, size of operator, and then address of operator. This is called it as address of. And then function call operator. So this is array index operator. Okay, this is function call operator. This is what we are calling it as array index. Okay, array index operator. So we have these special operators are there which are used for some specific purpose. So comma operator, if you are using that, it is used to separate the variable declarations and also used in expressions to assign rightmost value. This is very important. So when you are using here x equal to 5 comma 6, so x value is assigned with 6, not with 5. Fine. So if you write x is equal to a plus b comma a minus c, so what value it is going to be assigned? A minus c value is going to be assigned to x. So rightmost expression value is going to be assigned to this left side variable. Then next coming to this another special operator which is called it as a size of operator. So which gives how much main memory size that particular variable or data type is going to occupy. So it is going to give the size in bytes, how many bytes of memory that particular variable is going to occupy. So it may be a variable or it may be a data type. So here we are specifying a data type. So int size of int, that means int data type how many bytes it occupies in your computer. So it is occupying 2 bytes, so 2 is the output. So like that you can write it as size of for example a. So if a is an integer data type, it again gives 2. If a is a char, it gives 1. If a is a float, it gives 4, like that based on the data type of a. So the number of bytes that a variable occupies will be displayed. Then next coming to this expression. So what is mean by expression? So it is a sequence of operands and operators that reduces to a single value. Okay, so the expression can be a simple type or it may be a complex type. For example, if you take one operator is there, two operands is there, 2 plus 5 is a simple expression involving the addition. So if you take this 2 plus 5 star 7, so here we have a plus and multiplication. These are the operands. 2, 5 and 7 are called it as operands. So more than this particular type of complexity we can also involve by enclosing that expression in open and closed braces also. So when we have this precedence and associativity, so precedence is used to determine the order in which different operators in a complex expression are evaluated. Okay, how we can evaluate the operators in a complex expression. So based on the precedence, we can evaluate that. So C extend the concept to 16 levels. So that means here, for example, if you consider int a equal to 9, b equal to 12 and c equal to 3. So if you evaluate this expression, what could be the value of x? So a value is 9 plus b value is 12 star 3. So if you evaluate this expression, so how it will be evaluated and what could be the value of this? So we are going to consider precedence of the operators. So in this expression, plus and star arithmetic operators, both are arithmetic operators. So in this arithmetic operators plus and star will have highest priority than plus. So it will be evaluated first. So that means here it is going to get 9 plus 12 into 13, 12 into 3. So that is nothing but 36. Then now the plus operation is evaluated. Second time the plus operation is evaluated. So it is nothing but 45. 45 is assigned to x. Similarly, you take the second example here. So in the second example also x is equal to a 9 b 12 by 3 plus c value is 3 into 2 minus 1. So among these different set of operators that are involved, all are arithmetic operators involved here. So we have this star and slash. Star and slash will have more priority than minus, plus, minus. Okay. So among these prior operators, so first it will be evaluated as slash or star, because equal priority operators. These two operators are having equal. Star and slash will having equal priority. So we are going to consider left to right. So that is called it as associativity. So when equal priority operators you want to evaluate, okay, equal priority operators you want to evaluate, then the associativity is to be considered when equal priority operators are to be evaluated. So here if you evaluate that, so 12 slash 5 is evaluated first. Okay, so that means 9 minus 4 plus 3 star 2 minus 1. So next star will be evaluated. Okay, this will be evaluated next. So this is called as 9 minus 4 plus 6 minus 1. Now here we have minus plus minus. So all are only arithmetic operators, plus and minus, equal priority. So when equal priority comes, you will go for left to right associativity. Some operators will have also right to left associativity also. So here 5 plus 6 minus 1. So 5 plus 6 is 11, 11 minus 1 which is equal to 10. So now in this case 10 will be assigned to this x. This is how the precedence and associativity is taken. Precedence is used for which operator has to be evaluated first. Highest precedence operator is evaluated first. Then associativity is considered when equal priority operators are there. So which operator has to be evaluated first? Whether the leftmost operator is evaluated first or rightmost operator is evaluated first. That is left to right direction you have to evaluate, or right to left direction you have to evaluate. So that is considered with associativity. Fine. So this is what the table which gives you the precedence and associativity table. So please see that these are the different kinds of operators that we had already discussed. Okay, so this is also another important special type of operators. So this is a typecast operator, we are calling it as size of star, pointer in direction. This is a special operator, address of operator. Okay, so this is increment and decrement operators. Okay, this is a tilde is a complement operator, negation is a logical operator, function call, this are index, this is a dot and arrow. They are used when we are using the structures variables. Fine. So like this, if you see that these are the type of operators and then their corresponding associativity. So associativity is left to right here, and for unary operators the associativity will be right to left. So for all, most of the operators will have the associativity left to right, except this unary operators and then the ternary operator and then assignment operator. So assignment operator, ternary operator and unary operators will have the associativity right to left. Remaining all are left to right only. So tell me, when we are using associativity? Associativity is used to determine the order in which the operators with the same precedence are evaluated in a expression. Either it may be left to right or right to left. So here if you see that 3 star 8, slash 4, percent 4, star 5. Here all the operators will have the same priority. 4 operators are involving, all the 4 operators will have the same priority. Then their associativity is considered now, because the arithmetic operators will have the associativity left to right. So first we have to evaluate this 3 star 8. Then you have to evaluate slash 4. Then you have to evaluate percentage 4. Then you have to evaluate star 5, like that. Okay, so this is what you are doing here, grouping. So right to left associativity, the following example shows how right to left associativity will be there. So here A equal to 3, B equal to 4, C equal to 8. Then A plus equal to B star equal to C minus equal to 5. So it will be evaluated, which will be expanded like this. C, first it will be parenthesized. So that means right to left it will be parenthesized, because these operators will have shortened operations. So A plus equal to B, it's equivalent to A equal to A plus B. So try to understand that. So it will be evaluated like this. So once you expand this, the value we are going to get it as 15. So C equal to C minus equal to 5 means C equal to C minus 5. So it will be multiplied with B. So B equal to B star. Then it is equal to A equal to A plus B. So that is what it is doing that. So when we are evaluating the expressions, the rules for evaluation is first parenthesize the sub expressions from left to right are evaluated. If parentheses are nested, the evaluation begins with the innermost sub expression, first followed by the second, and so on. For any expression, precedence rules and associativity rules are applied for evaluation. So here we are given one example. So please try to evaluate. Evaluate the following expressions. So these are the values and these are the expressions we are given. 3 expressions are given here. So for your understanding, please try to evaluate it. So this is one reflection spot. In C language, associativity is applied when all operators in an expression are at the same priority or at the same level. State whether it is true or false. Any student can able to answer this one. It is right, true. So summary of this today's session is that, so in this particular session, we had a discussion on bitwise operators, so which are going to operate on the binary data, and there are some special operators, we have seen that, and also operator precedence and how the expressions are evaluated using operator precedence and associativity. So that we had discussed in this particular session. So lecture outcome is revisited here. After completion of this lecture, students will be able to develop the programs using bitwise and special operators. So this is what lecture level practice problem. So please try to solve this lecture level practice problem. It is very, very important here using bitwise operators, how you can determine whether a given number is even or odd. And additional problem is also given here to find the, to swap the two given integers using bitwise operators here. Fine. And write a program in C to display the memory size of each primitive data type variable. So these are the problems. So please try to solve it based on this particular session. So thank you. So if you have any doubts, just please let me know that. So if you don't have any doubts now, I would like to stop this session.